Hey guys, welcome back to the channel. Today we'll be solving LeetCode 205 isomorphic strings. So we're given two strings S and T and you want to determine if they're isomorphic. So what does it mean for two strings to be isomorphic? So for two strings to be isomorphic, every character in one string has to be mapped to one character in the other string. And when we map these characters to another character in the string, they're exclusive to each other. So if I map E to A, I can't then map A to something else. E to A, this goes both ways. They're mapped to each other. So in this case, this is isomorphic because E gets mapped to A, these two get mapped to each other, and then G gets mapped to D. And as you can see, when we get here, this is already mapped to D. So these two are connected and it's basically like pattern matching. So we can solve this efficiently using a hash table or a dictionary in linear time. And we're going to have constant extra space because we're working with the alphabet and we only have 26 letters. And at worst case, we're going to have to store 26 letters in our dictionary and each letter gets mapped to one other letter. So that's technically constant and not linear. Let's get into the explanation. Okay, so I'm going to use paper and title for my first example, and then I'm going to do another one after just to reinforce the concept. We're gonna basically just run through this, iterate through both of these at the same time. Since they're both of the same length, we can just use one iterator. And we're gonna have a dictionary where every time we encounter a character, we're gonna map them to each other. So that's why I'm using a double arrow in this example, because we're not just mapping one to this one, we're mapping this one to that one too. We're mapping them back and forth, so it's connected. So let's go through this example. We see P, we're at P, and we check, is P already in our dictionary? It's not, and then we check, is T in our dictionary? If these were in our dictionary and they were mapped to something that wasn't, so if P was in our dictionary and it wasn't mapped to T, then we would return false. And if T was in our dictionary already, so we already mapped it to something that wasn't P, we would return false. So we're just gonna map these to each other and then we're gonna keep iterating. And then we get to A, we see A is not mapped to anything and I is not mapped to anything either. So we can keep iterating. Then we get to here, we see P is already in our dictionary and it's mapped to T, which is what we want it to be mapped to. And then T is also in our dictionary, it's mapped to P, which is good. So we keep iterating. Then we get to E and we see it's not mapped to anything and L isn't either. So we add those. And then we get to R and E and they're also not mapped to anything. And at the end, we've iterated through both of them and we didn't return false, so we can just return true. So let's try this with another example just to reinforce the concept. So here's an example where we would actually return false because these two strings are not isomorphic. F is not in the dictionary and B isn't either, so we're just going to map F to B. And then we're going to move on to our next iteration and we see that O is not mapped to anything and A isn't either. So we can add this to our dictionary and then we get to here and we see O is already mapped to something, but that thing is not R. O is not mapped to R, but even though R is not mapped to anything, it doesn't matter because O is already mapped to something. So we can simply just return false right here because we know that these two strings are not isomorphic. So what is the time complexity of this solution? In this case, we have to iterate once through both strings. So our time complexity is going to be linear or O of n. And we're storing a dictionary. And although you may think that the or the space complexity is going to be linear as well, it's actually not. It's constant because we have 26 letters in the alphabet and we're never going to store more than 26 letters, which is a constant. So if our worst case is always going to be 26, that means that our extra space is going to be constant. So let's get into the code now. To solve this, we're going to initialize two dictionaries, one for the first string and one for the second string. And we don't have to check if the length of these two are equal because in the description they said we're guaranteed that the two lengths will be equal. And that's why we can use one for loop and just get the length of one of them. We don't have to use zip or anything because they can use the same index. And then we're going to have two checks. The first check is going to be if the first character in the first string is in its dictionary. And if it is, we want to make sure that it maps to the right thing. If it doesn't map to the right thing, then we want to return false. So we want to make sure that it maps to the current or the first character in the second string, which is going to be T of I. And if it doesn't, we're just going to return false because these are not isomorphic. And then we're going to just do the same thing with our second string's first character. And we're just going to change this to T dictionary 2. And we want to, this time we want to make sure that it's equal to the first string's first character. And if it's not, we're just going to return false. After that, we're going to populate the dictionaries like this. We're gonna map this character to this character. And I'll explain in a sec why we have to use two dictionaries because maybe that wasn't very clear. And after we've mapped them, if we don't end up returning false in any of these cases, we're simply just going to return true outside of the for loop. The reason why we needed two dictionaries to hold the characters for each string is because let's look at this example, for example, in paper and title. P gets mapped to T, A gets mapped to I, P gets mapped to T again, or it's already mapped, and it's so we're good here. Then we get to E, E gets mapped to L, and then R gets mapped to E. Now this is a valid isomorphic string because E got mapped to L, but R hasn't been mapped to anything yet. R is allowed to get mapped to E. This is why we need two dictionaries and we can't just have one.